The set of eigenvalues of which one of the following matrices is not equal to the set of eigenvalues of this matrix 1, 2, 4, 3 means matrix 1, 4, 2, 3, suppose having the eigenvalues lambda 1 and lambda 2, then option A, B, C and D, which one options not having the same eigenvalues, not having the same eigenvalues. So exact values of eigenvalues, value of eigenvalue will be for this matrix, as matrix is given and it is very low size 2 by 2 or small size matrix, its determinant is 3 minus 8 minus 5 and its product sorry, its trace is 4. So its characteristic polynomial or characteristic equation will be in terms of x square minus trace, value of trace is 4 and determinant is 5 equal to 0. So its factor will be x minus 5 and x plus 1 equal to 0. These are two factors implying that x equal to 5 and minus 1 are the eigenvalue for this matrix. In option A, this is non-diagonal elements only interchange, so value of determinant remains same as well as trace. Also you can check trace of this matrix in option A is 4 and as we find for given matrix is 4, so it is not our desired option because not equal eigenvalues. In option B, only principal diagonal elements interchange, so trace is same and determinant will also same as given matrix, so B is not right choice. Similarly for C, so trace in matrix D is 6, which is not equal to the trace of 4 given matrix, so option D is our right choice here. Let an be a sequence of positive real numbers. The series an converges if the series means 4 options we have, and in 4 options 4 series is given to us. Convergence of these 4 series implies the convergence of series an, means we have to check if option A is true, then series an convergent. Consider summation 1 upon n square. This converges by p-test, but summation 1 upon n doesn't. We, we all are familiar. This is not convergent. You can approach this by either definition or Cauchy nth test. So option A is not the right choice. Now come to option B. Is option B says summation an upon 2n square converges, means limit of an upon 2 raised to the power n will be 0. It is clearly understood. Now this converges implies imply or not convergence of an. Now consider this is as summation 1 upon 2 raised to the power n. Now this is convergent because of geometric progression with common ratio half less than 1. So it is convergent, but series this not because of an equal to 1 and this is not convergent. Or you can consider an as n and apply nth root test or Cauchy nth root test as n upon 2 raised to the power n. Its root, if we apply root test here, then limit of n upon 2 raised to the power n and its nth root will be less than 1 if convergent, and it is given that this is convergent, then this one will be 1 upon 2 raised to the power 2 and it is less than 1, but this one not convergent. So option B discard here. Now come to option C and D. We know that if an plus 1 upon an converges, then limit of an plus 1 divided by an equal to 0 or limit an plus 1 divided by an less than 1. We can say less than 1 because if this limit is 0, it means limit is going to be 0 for sufficient large n. For sufficient large n. And this is the condition by ratio test. This is a condition. If any series is convergent, then this condition should be fulfilled. Means if this we have, then we can say this one is true. Means this series convergent. So option C is nothing but ratio test. Now if C is true, then D automatically discard. We have ratio test in two format, or we normally write into types. If we see limit n tends to infinity un upon un plus 1, then this limit should be greater than 0 for convergence. If we see limit un plus 1 means n plus 1 in above or numerator and un in denominator, then this should be less than 1 for convergence. Otherwise, we have divergent. So option C is true here. Means if this converges, then series this one also. S and T be a linear transformation from a finite dimensional vector space V to itself such that S of T V equal to 0 for all V in vector space V. Then rank T greater than nullity S, rank T less than nullity S. It means if from option A and C, if one is true, then other will be false. Rank S greater than nullity of T and rank S less than nullity of T. It means from option B and D, if one is true, then other will be false. In all these four options, rank, rank of T, nullity of T, nullity of T, and rank of S, and nullity of S. We will discuss these 4 points as in 4 options asked about. As S and T are linear transformation from vector space V to V, and because this is a linear transformation, so it is necessary field must be same for vector space. And also it is given that a finite dimensional vector space, what will happen if it is not given to us a finite dimensional vector space? Normally I write FDV as finite dimensional vector space. If it is infinite dimensional vector space, then rank plus nullity equal to dimension of vector space V, or as a domain, this relation or equation will not hold more, because if one quantity or one expression is infinity, then infinity plus something will come to infinity, and we can't say about their inequality. because we can't compare two uncertain number, infinity and infinity, which one is greater, because they are so much large we can't compare them. So we adopt a symbol represent these are not comparable. Rank of T and nullity of T and rank of S and nullity of S we will discuss here. As S is a map and this S send all image of V to 0. This is image of T, and this is S. This S send all image of T to 0 vector. It means image of T means range of T is a subset because this is input for S, and all images of S send is 0. So range of T is null of S or null space of S, and this is based on finite dimension vector space V. So we can say that larger set or superset has greater superset, this is superset greater dimension, and this is subset, so it will have less dimension. Or so dimension of range T will be less than dimension of null space of S, and dimension of range T is, we normally write rank of T is less than nullity of S. So option C is true here. Now come to the other option, rank S. As we already discussed point, rank T is less than nullity of S, and we know rank and nullity equal to dimension of V. If one thing is we know, then other will be find by subtract from dimension of V minus something, either rank or nullity. So to obtain a relation minus either minus rank or minus nullity, multiply this inequality by negative sign. It means rank of T greater than nullity of S, and add dimension of V both side. So dimension minus of rank T greater than minus of nullity of S, and add dimension of V both side, and this one is also dimension of V. Dimension of V minus null S is known as rank of S, and greater than, and this one is known as nullity of T. So nullity of T is greater than r- r- rank of S. Nullity of T greater than rank of S, it means option D is true. So C and D are our right choices. Let n be the sequence of the real numbers such that a1 equal to 1 and an plus 1 equal to an plus an square for all natural number. Then a4 be this limit of 1 upon an equals 0, limit of 1 upon an is equal 1, and limit of an is equal 0. Means we have to tell about limit of an or limit of 1 upon an, and need to check a4 is equal to option A and option A. It means if we to verify, then there is no need to check other one. As a1 equal to 1, and iterative formula for coming terms is given to us an plus an square for all n. From this formula, A2 equal to A1 plus 1 square means 2. A3 will be A2 plus A2 square means 2 plus 2 square means 6. A4 equal to A3 plus A3 square means 6 plus 6 square. This will give you 42. Means limit of, you can see this is not bounded. So limit of n equal to infinity means limit of 1 upon an equal to 0. Means you can see option B is true here. Now come to option A. As A4 equal to A1 for option A4 equal to A1, 1 plus A1 plus 1 plus A2 plus 1 plus A3. Now A4 is giving 42, so left hand side is 42. Now check this right hand side is giving 42 or not. If giving 42, then option A is true, otherwise not. Now A1 is 1, 1 plus 1, 1 plus A2 is 2 from by computation, and 1 plus A3 is 6. This give you 1 into 2 into 3 into 7. 7 3 is 21 and 21 2s are 42. Means left hand side is equal to right hand side. This one is true. So option A is true and option B. Both are true options. And option D discard because limit of an is infinity and limit of 1 upon an is 0. So option C discard from limit of an. Let W1 and W2 be subspaces of the real vector space R100 defined by this set. W1 is defined by this set and xi equal to 0 if I is divisible by 4, and W2 is defined by this order pair where xi is equal to 0 if I is divisible by 5. Then the dimension of the intersection of W1 and W2. So we have to find dimension of W1 intersection W2, and W1 dimension of W1 will be dimension of V minus number of restriction. And how many restriction? As xi equal to 0 and I is divisible by 4. So how many I are, how many or number of I is up to 100, up to 100. So least I will be 4 and larger one will be 96. So divisible by 4, it means next term will come by 4 plus 4, it means 8. Then 3 times 4, 12. It means this is the AP arithmetic progression. So how many terms are there? A plus n minus 1 into D. You can find number of terms by this because we know first term and common difference. This is 4 plus n minus 1 into 4, 4 plus 4n minus 4 and equal to 100. So n equal to 4 2 is 8 and 4 5 is 20. So number of terms are 25. So dimension of W1 is 100 minus 25. 100 minus 25 equal to 75. Dimension of W1 is 75. Now you can find dimension of W2. You can find dimension of W2 in similar fashion. How to find? As least number be 5 and larger or largest number up to 100 is 100. So by formula L equal to A plus N minus 1 into D, or you can say this is last term or nth term. So A plus N minus 1 into 5, because common difference will be 5. So this 5 cancel out by this, and 100 equal to 5n. So n equal to 5 to 10, 20. So dimension of W2 will be 100 minus 20 equal to 80. You can find dimension of W1 plus W2 and apply the formula. Dimension of W1 plus W2 equal to dimension of W1 plus dimension of W2 minus dimension of intersection. So, or easiest one to find dimension of intersection, you can take an element in intersection, then by the property of intersection of two sets, y will be, suppose I am taking normally y, so y if intersection, then y is in W1 and W2. So y in W1 and y in W2. If y in W1 and W2, then y will satisfy properties of W1 and W2 together. So as we are saying that to find dimension of common, so y in W1 and y in W2, so y will satisfy property of W1 and W2, and this is based on xi. This is W properties of W1 or W2 is based on xi, and xi are zeros. So we have to find we are restricted or we are bound at how many places. So to find dimension, suppose W1 may be x1, x2, x3. Suppose this is W1. If someone is 0, then dimension of W1 will be 2, because we are restricted here or we are bound to take this position as 0. So we are independent at only 2 choices, and number of independent choices is known as the dimension. Number of independent choices means number of linearly independent vectors. So how to, you can take x1 and 1 0 0 and x2 0 1 0 and x3 0 0 0. So only these two are independent vectors. So dimension of W1 equal to 2. So also you studied that a linearly independent set can be extended to form bases if number of linearly independent vector is less. So we can put number of linearly independent, because basis is largest linearly independent and spanning set, or in other words you can say basis is smallest spanning and linearly independent set. So we have to check at how many places we are restricted for element y. We have to find number of restriction for y, number of restriction for y, and take 100 minus number of restriction. That will give you the dimension of intersection. So from, if I running from 1 to 10, I is running from 1 to 10, so up to 10 I is divisible by 4, so 4 and 8 will be number. And if I is divisible by 5, then 5 and 10 will be two numbers. These are for 5 and these are for, so total number or total restriction up to 10 is 4. Total number of restriction is 4, and up to 20, 10 to 20 there will be 4 restriction. 30 to 40 there will be 4. So up to 100 we break or we resolve 100 up to 10 parts, and in each part 4 restriction is there. So total restriction 10 into 4, it means 40 restriction. So you can take 100 minus 40, you can take 100 minus 40 as the dimension. So dimension of this 100 minus 40 equal to 60. 60 is your final answer. Or you can take common basis for W1 and W2. Also, if you approach in other way, because the dimension of W1 is 75 and dimension of W2 is 80, so there will be some number as will be common, because as I is divisible by 4 and 5, so 20 is a number which is divisible by both number 4 and 5. Similarly, there will be more number, 40 will be there, 60 is one of them, 80, 100. So some number are which are divisible by 4 and 5 together, so they will be need to take ones.